Good morning all. So I'll be dealing with the module 3 of computational linear algebra. So in this module we will be discussing the key topics: characteristic equation and eigen decomposition, diagonalization and spectral theorem, power method and iterative approaches, applications where we have the stability analysis, and also we'll be going for the principal component analysis, and we have the lab including computing eigenvalues and eigenvectors using NumPy. And basically coming to the learning outcomes of the session, we have solving characteristic equations, performing eigen decomposition, and how to apply diagonalization, then utilize the spectral theorem, and also to analyze the stability. So in this module, in the last module, we have learned what is a matrix and also certain properties of the matrix. And in this particular session, we will be dealing to find the eigenvalues and eigen vectors of a particular matrix. So for that we require the first topic, what is the characteristic equation of a matrix. So we'll be going into that. So we have the characteristic equation and eigen decomposition. So what is the characteristic equation of a particular matrix? We'll assume that A is an n by n matrix, which is a square matrix. Then the characteristic equation of A is defined as a function f of lambda and is given by f of lambda is the determinant of A minus lambda I, where I represents the identity matrix. So in order to find the characteristic equation of a particular matrix A, what we do is we find the matrix A minus lambda I. Our A will be given as shown here, and then what we do is A minus lambda I. So in order to get A minus lambda I, we subtract lambda into I, which will be lambda 0, 0, lambda, and it will be subtracted from E. So this will basically be 3 minus lambda, then here it will be 1, and here it would be 2, and here it would be 4 minus lambda. So this particular A minus lambda I will be a matrix, and taking the determinant of this particular matrix will give you the characteristic equation. So what is the determinant of this particular A minus lambda I? That is 3 minus lambda into 4 minus lambda minus 1 into 2. So yeah, here is the determinant. While opening the brackets and simplifying this expression, we'll be having 12 minus 3 lambda minus 4 lambda plus lambda square minus 2, and taking this 2 to inside of 12, it would be lambda square minus 3 lambda minus 4 lambda will be minus 7 lambda plus 10. So this particular polynomial is called the characteristic equation, and as you can see, it is a second degree polynomial. Since we had a 2 by 2 matrix, we will be having a second degree polynomial. Instead of 2 by 2, if you are having a 3 by 3 matrix, it will be a third degree polynomial. And if it is an n by n matrix, we will be having an nth degree polynomial. So in order to get the characteristic equation, what we do is just find A minus lambda I and then the determinant of that particular matrix. And now let's try out some problem of a 3 by 3 matrix. We are given A is equal to 2 1 0 1 2 1 0 1 2, and in order to get the characteristic equation, what we first do is find A minus lambda I. So A minus lambda I is given here. So you can see A minus lambda I, since I has only the diagonal entries, will be having minus lambda. So this will be something like this. So all the 2 in the diagonals will be having 2 minus lambda, 2 minus lambda, and 2 minus lambda. Other entries remains the same since 0 is subtracted from all those entries. And then finding the determinant of this particular 3 by 3 matrix, it would be 2 minus lambda into determinant of this particular matrix minus 1 into, and we will be deleting, since this is 1, we'll be deleting the first row and the second column, and then we'll take the determinant of the remaining matrix, which will be having the first column as 1 0 and second column as 1 2 minus lambda, and we'll be having this particular thing as its determinant, and then we'll be finding the determinant of this particular 2 by 2 matrix, which is 2 minus lambda into 2 minus lambda minus 1, and here it is minus 1 into 2 minus lambda minus 0. So that would be minus 2 minus lambda, and then we'll be we'll be simplifying the brackets inside. So as you can see, here we have a 2 minus lambda, and also here we have a 2 minus lambda. So it would be easy for us uh, if we take the 2 minus lambda outside. So this will be equal to 2 minus lambda into, so we'll be having this thing in the bracket, and also here we have a minus 1. So this particular minus 1 and this minus 1 will give you minus 2. So this is a simplified, more simplified form. And then you will be having 2 minus lambda into, you'll expand this bracket, a minus b, the whole square is a square plus b square minus 2ab. So you have 4 square minus 4 lambda plus you will be having lambda square. So this is what you have, and you can just open the brackets. You can multiply 2 to these 3 terms and then subtract negative, then add distribute negative lambda to all these terms, and you have the characteristic equation. So the characteristic equation is determinant of a minus lambda I equal to 0. So our determinant is this one. So this is equal to 0. Det of a minus lambda I equal to 0 will imply this particular equation. This particular equation is equal to 0. So if this is equal to 0, since you in order to make the first term, in order to make the term with the highest power positive, you can take negative from all the terms outside. So this will become positive, this will become negative, and this will again become positive, and this will become negative. So we have this as the characteristic equation. Hope you got that. To find the characteristic equation, just find the value of a minus lambda I, then take its determinant to be equal to 0. You will be getting a particular polynomial, and that's the characteristic equation. Hope you got. Now we'll be moving on to the eigenvalues of a matrix. The main reason or the main application or the main use of a particular characteristic equation is to find its eigenvalues, eigenvalue of a matrix. So basically, coming to the eigenvalue of a matrix, how will we find it? We know now how to find the characteristic equation of the matrix. Then that particular characteristic equation is a polynomial, maybe in a second degree or third degree based on your syllabus. So you can factorize them. We know how to factorize a second degree polynomial or a third degree polynomial, and then the roots of that particular characteristic equation is called the eigenvalue of the matrix. So coming to the definition of the eigenvalue of a matrix, the roots of the characteristic equation of a particular matrix is called the eigenvalue of the matrix. For example, we have the same matrix we had before, which is A is equal to 3 1 2 4, and now suppose we are finding the character, we have already discussed about the characteristic equation of the same, and that is lambda square minus 7 lambda plus 10 equal to 0. And now we'll try to factorize this, and when coming to the factorization, we'll use the splitting the middle term method. So here we have minus 7 lambda and we have here 10. So in order to make the product 2, so we'll be, in order to split these terms, we will be considering two numbers whose sum is negative 7 and whose product is 10. So they are minus 2 into minus 2 and minus 5. Their sum minus 2 plus minus 5 is minus 7, and minus 2 into minus 5 is 10. So you can use this particular numbers to split this minus 7 into minus 5 lambda minus 2 lambda, which is minus 7 lambda itself. So you can split this minus 7 lambda, this two terms, and this particular method is called as splitting the middle term method. And then what you can do is you can take lambda out from the first two terms. Since you have lambda square here and minus 5 lambda here, what you can do is, first you group this one as lambda square minus 5 lambda minus 2 lambda minus 10, and then you can take lambda outside from the first term, so that will be lambda minus 5, and from here what you can take outside is 2. So take 2 outside, so it will be lambda minus 5. So you will have this one. So this will be equal to, now when comparing, you have lambda minus 5 is common in both the terms. So just take lambda minus 5 outside. So you will be having lambda minus 2 inside. So this will be your particular factorization. So after factorizing this into linear terms, and you can see this particular equation is equal to 0 when lambda is equal to 5 and lambda is equal to 2. So these particular values, which are the roots of the characteristic equation, are called as the eigenvalues of A. Okay, so a particular matrix will be the eigenvalue of a particular matrix are the roots of the characteristic equation. And if it's a 2 by 2 matrix, if it is a 2 by 2 matrix, you will be having two eigenvalues. Okay, it can either be real, it can be equal, it can be complex, whatever, but you will be having, if you are having an n by n matrix, you will be having n eigenvalues. Okay, so that's it about the eigenvalues. So what we do is just find the characteristic equation A minus lambda I, and then its determinant equal to 0, and then find the roots. That's it. Now, yeah, we have a same 3 by 3 matrix where we discussed the characteristic equation before. So here also we'll be forming the characteristic equation we have already. And in order to factorize a third degree polynomial, or in order to find the roots of a third degree polynomial, we have a we have one more root. So we can't use the splitting the middle term methods. What we do here is we'll just see the constant term. So here the constant term is -4, and we'll list the integers which divides -4. So that will be plus or minus 1, plus or minus 2, and plus or minus 4. These are the 6 integers which divides the constant term. Then what you do is just take this polynomial and apply all these values to lambda and see for which value of lambda this polynomial is equal to 0. Okay, for example, let me take the polynomial to be lambda cube minus 6 lambda square plus 10 lambda minus 4 is equal to 0. My first value is 1. Okay, so let me substitute lambda equal to 1 in this equation. So that would be 1 cube minus 6 lambda square, which is 6 1 square plus 10 1 minus 4. So you have this value is equal to 1, which is not equal to 0. And now what you do is you should try minus 1 also, since I have not tried it here, but you should try minus 1 also. Then we'll go for 2. So going for 2, when lambda is equal to 2, what happens is we have 2 cube minus 6 2 square plus 10 into 2 minus 4, and this particular value is equal to 0. Okay, so when this value is equal to 0, the meaning is that particular number, that particular value of lambda is a root of this polynomial, which means lambda equal to 2 is a root of this polynomial. So this particular polynomial is divisible by the term lambda minus 2. If lambda equal to 2 is a root, then lambda minus 2 is a factor of this polynomial. And then what we do is we'll just divide this polynomial by lambda minus 2. So we have the synthetic method, and for that what we do is we'll list the coefficient of this polynomials, which is we have for lambda cube the coefficient is 1, for lambda square the coefficient is -6, for lambda the coefficient is 10, and the constant term is -4. We'll list them, which is given here, and then what we do is we'll just draw a horizontal and a vertical line, and we'll write our root, which is 2 here. Okay, now to divide them, what I do first is I will just write this term here. Okay, I will just write the first term straight to the bottom, and then what I do is I will multiply this term with 2. So I have 2 into 1, and that is 2. So I write this 2 here, and now I add this minus 6 plus 2. Answer is -4, so I will be writing it here. Okay, and then what I do is I'll again multiply 2 into -4, and the answer is -8. Now when adding this 10 minus 8, I have 2. Again what I do is I'll multiply 2 into 2, which is 4, and I'll be getting 0. Always I will get the last term to be 0 if this particular number is the root of this characteristic equation. My last entry will be 0. So now I have some terms, which is 1, -4, and 2. Okay, give it to the, so since it was a third degree polynomial and we have one root, so this particular terms will be the coefficients of the second degree polynomial. And how we write it is 1 into lambda square, then we have negative 4 into lambda plus 2. So this is the particular polynomial what we need. In short, this lambda square minus 4 lambda plus 2 into lambda minus 2 is equal to our polynomial lambda cube minus 6 lambda square plus 10 lambda minus 4. Okay, what you do is just do the synthetic division and just factorize. And now we have a second degree polynomial, and either we can use the splitting the middle term method, or we can use the formula of minus b plus or minus root of b square minus 4ac by 2a. It can be done also. So when comparing this to here, here the problem is you can't just find the two numbers whose sum is negative 4 and the product is 2. You will not be able to get it in a quick way. Okay, so what we do is we'll just find the value of b, a and c. So what we do is here the value of a is equal to 1, value of b is equal to negative 4, and the value of c is equal to 2, and we'll just apply to the equation lambda is equal to minus b plus or minus root of b square minus 4ac by 2a, and we'll apply the value of a equal to 1 and b equal to minus 4 and c equal to 2 here, and then we'll be having lambda is equal to minus of b is minus 4 plus or minus root of minus b square minus 4ac, and then we'll be getting a number 4 plus or minus root 8 by 2. So root 8 can also be written as, you can take the 4 outside, so it will be 2 root 2. Is it? Yeah, it is 2 root 2, and then cancel this 2. 4 divided by 2 is 2, and then this 2 will be cancelled, so this will basically be 2 plus or minus root 2, which means we have the roots. One value of lambda was equal to 2, and the other two values are 2 plus root 2 and 2 minus root 2. They are the eigenvalues of A. Okay, so what we basically do to find the eigenvalues are, we find the roots of the characteristic equation. If it's a 2 by 2 matrix, just follow splitting the middle term method, or just use this formula to get the roots. And if you're having a 3 by 3 matrix, find the characteristic equation, and then what you do is you need to find one root by the trial and error method, and then follow the synthetic division, get the second degree polynomial, and then again use this formula to get the other two roots. Okay.